All right. Get started. Welcome to session 3 for Python 201. This is today we're doing reshaping and merging. I'm adding code to the Moodle right now. It's up on the GitHub. Oops, did I not change this? So it's here. And for today, in addition to this code, we'll also need actual ag and plans, these two Excel files that we worked on the last 2 weeks. Just update the Moodle here real fast. Okay. So this is the code for session 3, shaping and merging. It's actually reshaping. So in session 1, we covered data frames. We talked about basic operations on data frames, or in SQL, I guess we call them tables. Select, selecting rows and columns, adding and dropping rows and columns, reading and writing data frames to Excel files, to and from Excel files. And last week we talked about aggregate functions on groups of data, aggregate statistics, and sorting values. Today, shaping and merging data frames, I think, is one of the most fundamental skills in data science. I think merging data sets is one of the most fundamental skills in data science that separates those analysts who are familiar with statistics and using a ready-made data set versus those who can actually manipulate data. So when we talked, session 2 and session 4 are about manipulating data inside of a single table. For example, grouping, grouping by one or more variables, sorting by one or more variables. All of these functions that we're doing, all of these operations we're performing in session 1, selecting rows, dropping rows, columns, right? Sorting and grouping, all of these things that we're doing in sessions 1 and 2, and also everything that we'll do in session 4, are all operations on a single table. Right? And if you can master those skills, you're a lot of the way there. But really, I think the key skill that kind of moves you to the next level in data science is being able to merge different. First of all, wrangle different types of data sets into the right format and then merge them. Right? And that's really a kind of intermediate to advanced skill that really sets apart very capable data scientists versus ones who are just kind of dealing with, can only handle like the table of data that they've been given. Right? So, and why is merging data frames so important? So a lot of times, say you're building a regression model, you have the outcome variable. What if your outcome variable is in one table, but your predictors are in another table? Right? And then if you want to build a regression model, you need to merge those two tables so that your outcomes and your predictors are in the same table, so that then you can, do regression on it. Right? Or oftentimes, maybe you'll have the data that you want, but then a new variable pops up. Or maybe you're doing waves of surveys, and you have data from, say, 2 or 3 waves of surveys, and then they just did another one, right? And now you need to add that data merge it with the table so that you can add that to and extend your analysis for the additional wave. Right? So it's either over time or adding new variables or whatever the case is. And I think the most exciting part in social science, I mean, this is true in business as well as research, being able to take data from different sources. For example, maybe you have customers and you have a customer database, right? And then you also see that customers are putting posts on your Instagram page, right? And so you have data about how much customers have spent and what they've purchased and what they like, what their kind of purchasing profile is. But then you also have their social media profiles or their actions or interactions with your site on social media. And if you can merge these things now, you can see, what types of customers are saying, commenting about what types of products, and so you can really leverage the data if you're taking data from different sources and then combining it. It just gives you so much more power. So that's my mini motivational lecture on why merging is so important. So let's jump into it. So first, I want to examine the two data sets that we've been looking at. We've got plans and we have actuals. Remember, in our original data, we had, this is the original file, hotel analytics. So this is our something's funky. Maybe I have too many screens up. So this is the revenue plan for 2019 in the hotel that we're looking at. And you'll recall we had 6 types of rooms across 12 months and several statistics, including different types of revenue and number of rooms, and then some summary statistics here. So these were the plans. These figures are aggregated over. I mean, they're not aggregates, but they're estimates. They're estimating aggregate revenues. So they're planning for this type of room in a particular month, for this type of revenue, what will be the total revenue for the rooms, rentals, or the food or the bar. And then actuals are the actual room reservations, and we also have the month and the room type, but the units of analysis of these two tables are different. The unit of analysis for the actuals table is the individual room reservations, and the unit of analysis in plans here is actually an aggregate unit. It's a sum of the revenue for a particular room for a particular month. So in order to compare the revenues with the actuals, we need to get them on the same unit of analysis. And since you can't, so our options are, we can't disaggregate the plan, right? So we have to aggregate the actuals, and then we can compare those. So, so we have the actuals here. And this is already nicely formatted for us, and we played with this and we added some aggregate statistics. We actually aggregated this last time here into this file, or we in Pandas, and then saved it. So here we aggregated our 15,000, 14,000, however many individual reservations to room type and month, and summary statistics on those. The days stayed, reservation counts, days stayed, and the 4 different revenue sums. So let me plug in my laptop. This will be a very short tutorial. So with revenue ag, with actual ag here now, these are the same units of analysis in plan, right? It's sum of revenue, food, beverage, and room by room type by month. So we want to just merge these two into the same data set so that we could compare them side by side. But the problem is that these two data sets are not shaped the same way. So what do I mean by that? So this is plans. This is it's this data set here that we created the first week. So this data set, in this data set, room type is long, meaning that the variable name is at the top and all of the variable instances of the variables are vertically, are going down with each of the rows. So room type is long, room stats is long. So these room stats are long. We have all these different revenue types. But month is wide. So what wide means is that you have one variable. It's when a variable is extended horizontally across as columns. Right? So here, the room stats, which are like sum of revenue total, sum of revenue rooms, food, bar, those are long, those are vertically oriented, but the months are horizontally oriented. Right? So normally we say long and wide. So room type is long, room stats are long, months are wide. But if you look at actual aggregates, what about, let's look at those three variables now. Room type is long or wide? Is room type long or wide in this data set? It's long, right? Room type is the variable name at the top, and then you've got the different room types. What about month? Is month long or wide? Here, month is long, right? In the other data set, month was wide, right? January, February were the column headers. What about the room stats? Long or wide? So all those like revenue sum, wide, right? Here the room stats are wide because each column is the day, right? The reservation counts, the days stayed, the revenue room sum, the revenue food sum, the revenue beverage sum. They're all columns across the top, right? So here, let me just make a quick. So in plans, room type is long. This is actual ag, right? Yeah, room type. So in plans, let me close this one. In plans, room type is long, room stats are long, and months are wide. And then in actual ag, this is aggregated actuals. Room type is long, month is long, and room stats are wide. Okay. So these, when we say these files are shaped differently, that's what we mean. that some of the variables are long and some are wide, and in the other data set, it's some other variables are long and wide. They're not the same variables are long and wide in the same data sets. So eventually we're going to merge these two, right? We're going to merge them and then we want them. But what do we want our, this is kind of a mental exercise. What do we want our merged data set to look like? So here's our merged data set. So we're going to have room type somewhere. Do we want the months to go across the top, January, February, or do we want them long? And what about room stats? Do we want the room stats long or wide? So think about if we're going to make comparisons. So think about, like, there's no right answer to this. Right? Yeah, if you want, and then there's actually going to be a fourth variable that we add in if we merge these two, right? Which is whether they're actual or planned. Because right now we've got room type month and room stats, two versions of those same, right? And one of them is the estimate and one of them is the actual. So that means we're going to have a fourth variable here, which is planned or actual. And we have to deal with that as well. So what do we want this data set to look like? Well, what the shape of the data set that we choose should depend on the kind of analysis that we want to do. And a lot of times you might find yourself taking the same data and reshaping it several times throughout your analysis because you want to do different kinds of analysis, right? So, but in this case, remember what was our first task that we were given? We had two basic tasks that we were going to do in this exercise. The first task was, what was our first task? What was the first analysis that we were going to do with this data set? So our first task is to compare actuals and expected and see for these summary statistics. For the summary statistics, like for example, revenue total, revenue rooms, revenue food, revenue bar, we want to compare the actuals and the planned and see, do they match? Did the actuals meet the plan, or were they under the estimate or above the estimate? And remember, specifically, we wanted to see, did we fall within 90% of the plan? Right. So, for example, if our sum of revenue total, our plan for this Club Deluxe King Room in January is 304,000, did we at least hit 90% of that, or did we hit below 90% of that plan? So that's the first analysis that we want to do. So, and if you want, so if the analysis that you want to do is comparing the plans to the actuals for each of the summary stats, then we want those to be across the row, the column headers. So I'll say it one more time. If the variables that we want to compare, the various types of room stats, right? Compare the actual and the planned. If that's what we want to compare, it's easiest if those are side-by-side columns, right? So that means we want, for each type of room stat, we want those to be a column across the top. And for all of the other variables, which these are grouped on, like room type and month, we want those to be long. So our data set, we want room type and month to be long. And then let's take a few room stats here. We'll take let's take these four, or let's see, reservation counts. Well, these are the statistics we can compare. Because reservation counts and days stayed, I think, did not appear in our plan. So we can include those as columns, but we aren't going to be doing any comparative analysis on those because we don't have a plan for that. But probably, I guess we could back calculate it, because that's probably how they calculated these totals anyways. But that's first things first. So So these are the three summary statistics. These are the three room sets that we want to look at, and we want to compare them as actual or planned. So here we're gonna, if the room stats are long and we want to make them wide, then in Python, in Pandas, let me see, are we doing long to wide or are we doing wide to long? Okay, so let's do this one first. So in Pandas, if you want to reshape a variable from long to wide, then you use the pivot function. So which table, so we ultimately we want to make room stats wide, and we want, so we'll get rid of that variable, and then we'll have each of these variables up here. Right? So we'll have revenue room sum, revenue room, revenue food, and revenue beverage. Right? But and then we're going to have two versions of those. We're going to have planned and actual. So that needs to be part of the variable name, right? So we'll have revenue room planned. Here, planned, planned. So we're also taking planned or actual, and we're going to represent that as wide as well. Right. So we're actually crossing these two variables. We're taking the planned or actual variable and the revenue, the room stats variables, and we're crossing them. So we have three room stats and two planned or actual, right? And then if you cross those, you're going to get 6. So repeat these. I'm just going to get rid of some here because it's making these too long. I'll get rid of revenue too. I'm just going to call this food planned. Let's just make these simple. Room planned and beverage planned. And then to do the comparison, then we'll want room actual, food actual, and beverage actual. So in the end, we want, for the merged data set, we want room type to be long. We want the month to be long. And then the ones that we're going to do the analysis on, we want our room stats wide and our actuals versus actuals, actual or plan will also be wide, which means that we're going to have room stats times actual or plan as wide. Okay, so in that case, if this is what we want, then before we merge these, we need to get our plans and actual shape the same way. So what's different about plans and the merged? Room type is long. Room stats is long, but we want to make it wide. Months is wide, but we want to make it long. Okay. So, so the first thing we need to do is take our plans data frame, and we need to make room type, room stats. We need to use pivot, the pivot function, to make it, change it from long to wide. And then we need to use melt which is the other function, to make months, which are wide, to make those long. And then what about actual ag? Room type is long, that's fine. Month is long, that's fine. And room stats are wide. So actual ag is already shaped the way we want it to be. Right? So plans is the one that we have to manipulate. And I'll just tell you, like, this is a very common situation when you're taking data table, like table data like this, which is made for report format for easy visual comprehension. These are the ones that you're usually gonna have to shape. Right? When the data was like presented for humans, that's the one you're gonna have to reshape, because the data that was the data that looks like this, right, was already, it was already ready for analysis. This is ready for the stats. This one that they made up nice for the CEO, right? That's the one you're going to have to manipulate and shape it back into something analysis friendly. So okay, so first let's melt those months. So the months in plans are wide. Across the columns we have January, February. Right? So let's melt those. So here we have plans, January, February, March, April, da, 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 da. And, oh, I should have just kept it how I had it. Okay. So we're gonna melt, so this is in plans. We're gonna melt months from wide to long. And then also in plans, we're going to pivot room stats from long to wide. And then we'll be ready to open actuals and then merge the two. Right? So, okay, so melting, let me show you, looks like this. So for melting, you use, it's a function of pandas, it's not a function of the data frame. So when we use this, we'll call pandas or pd.melt, and then the first variable is the data frame, and then the ID variables are identifier variables. These are the variables that we are not going to pivot, I believe. The ID variables are the variables, the format where one or more columns are identifier variables. So anything in your table that you don't want pivoted from long to wide, you have to identify as the ID variables. Otherwise, it'll pivot everything. Right? So ID variables are the ones that are long that you want to stay long. And then value variables are the columns that you want to unpivot. Oops, sorry. Melt is from wide to long, right? So yeah, sorry. ID variables are the ones that are long that you want to stay long. All the value variables are the columns, the variables across the column labels, which you want to unpivot, or you want to melt into long. So it'll make more sense if we do it. And then and also we're going to need a variable name, right? Because we've got the column names right now for the months are just January, February, March, April, right? When we unpivot those, when we melt those from wide to long, then that column is going to need a variable name, right? And I guess like the obvious variable name would be months. Right? So, okay. And then ignore index, true, column level, value name. Okay, so let's try this. So here's plans here, and we're gonna, first I wanna drop this unnamed. Okay. It was being overly helpful in indexing rows that we didn't need. Okay, so here's plans. Room type and room stats, I want to keep how they are. So I'm going to do plans here is PD melt plans. And then my ID variables are going to be room type and room stats. And this is going to be too long, right? So I'm gonna just make ID variables here. Let's call these IDs. ID variables and then we've got value variables. And those will be the month names. And then the variable name. So variable name is going to be month. Okay. I could, so the ID variables is going to be this list, ID vars. Value variables. So if I don't specify it, it will use all the columns that are not set as ID variables. And this is very convenient, right? Because I don't want to write out all 12 months. So here I've already identified room type and room stats as ID variables, and all the other variables in this data frame, right? All the remaining variables are the months. So I could write those out here, January, February, 12 variables, but I can just leave that blank. And then just I choose a variable name equals var name, which is month. Right. So variable name, it gave a month a name, but then the numbers itself, it also gave a value. So that's the default name for so variable name is month. That's the variable that you melted. And then the numbers, it just gives this name value. But we can also, we can change that if we want, but I think value is as good as anything. It's not going to matter because when we next move, we're going to take the room stats and pivot those from long to wide, and then that value is going to disappear anyways. So for now, that's fine. So this is exactly what we wanted. So we just melted month, right, from wide to long, and that was our first step. Okay, and then in step 2, let's call this. Okay, so in step 2, step 3 now in plans, we want to pivot room stats from long to wide. So it's a similar function, but just in the opposite direction. So, and we use this function called pivot. So here pivot is a function of the data frame, not of pandas. So to use pivot, you're going to put the name of the data frame dot pivot. Right? For melt, it was a function of the pandas module. So we had to do pd dot melt and then put the data frame inside. Here, the data frame is the pivot is a function of the data frame, and then index. Let's see here. So the reshaped data produces a pivot table based on column values, uses unique values from specified index columns to form the new axes. So that whatever we put here for index, just like with melt, that's what's going to stay. If it's long, it's going to stay long. And whatever we put for columns, whichever variable we put for columns, that's what's going to be kicked out. So, and then the values are the values that are going to be redistributed. So here in our newly shaped plans, room type and room stats are going to be index variables. They're going to stay the same. Month is, sorry. Room type and month are going to be the index variables that stay long. Room stats is going to be the columns. Those are going to be the new columns. And then the value column are the values that are going to be redistributed. So, so we can take plans dot pivot. Plans equal, is this going to be in place? Is this an in place operation? Or does it just, well, we'll try it this way. Okay, plans dot pivot. So the index equals room type and month. And then columns equals room stats and values. Is it value with an S or no? Yeah, values are values. Our value. So this the columns, this room stats column and the value column are going to disappear. Right? And then room stats here, that room stats variable name, that column name is going to disappear because all of these, the room stats are going to be flipped as column names, right? And then the values are going to be redistributed or pivoted across those new columns. So let's run this. Okay. So we've got room type, we've got month, and then for the room stats, we've got all of these stats, right? So these were all the different types of stats that we had: average of the ADR, average occupancy, number of rooms, sum of revenue, sum of let's see, bar, food, rooms, total, lots of other summary statistics. Right. Okay. Remember that if you see the room type and month now have been turned into, these are not ordinary columns, these are indices. You can see that because they're bold, right? And we don't like that. We don't want that because we can't manipulate them as easily. So I'm gonna remove the indices. And let me recall, I guess we did that in here, session 2. Was it? I reset index, that's right, that's right. And is it like in place or? So we can do it in place and drop is true. Oh no, we don't want to drop it. We just want to, let's try it. Okay. Yeah. This room stats, it's still sticking around. I think we could have, maybe we could have dropped it. I don't know. Or is that an index? I can't really tell. Room type. Something about it must be it might just be the name of the index or something. So when you do the pivot, it creates, so there's these levels and axes. So in axis, you've got the x-axis and the y-axis, or sorry, the index axis and the columns axis, but then they also have these levels, and it, when you remove the index, it gets rid of this, but I don't know how to like unlabel that level. But so anyways, for now, I'll just leave it alone. Okay, so all right, we've got that. So why do we have these room type and some statistics here where the room type is null? So remember, let's look at the whole thing. Remember we had that let's look at the whole. What's that? Yeah, it looks like these are totals. So the totals here, right? And so you can see it's kind of a 0, 1, 1, 0 matrix, right? So when for the totals, these room types, when the room type is null, then all of the monthly statistics are the sums are all null, but then you have these totals, right? And then when you get down here to the actual months, the rooms, then the totals are null. So actually, we don't want either of those. We only want this like bottom left-hand quadrant of the matrix. Right? So because that's what we're going to merge with the other table, so or data frame. So for now, let's just let's clean this up. So plans, we're going to drop no plans. We only want to include where room type is not NA. So we can do this. Plans where plans.room type is NA and then the opposite of that. So that means it should give us that should remove all of the null values. So we can save plans as that. And that'll drop those columns. Right. And then we also want for now, the only variables that we want to keep are room type, month, maybe number of rooms would be helpful, and then these revenues, and then these total columns we don't need. So let's make a subset columns to keep. So we want room type, month, number of rooms, sum of revenue bar, sum of revenue food. Okay, and actually I'll just okay. So those are the columns that we want to keep. And then so let's just do plans equal plans. And you can just enter this in here, columns to keep. Oops. Okay. And now we've got that. I think if let's try to reset that index and maybe that room sets will go away. I don't know. Oh, no such luck. All right. So, okay, that actually looks pretty good. So I think we're ready to merge this. So we've spent about 45 minutes talking about reshaping, right? Now let's spend the rest of the time talking about merging. So this, let's look at our actuals now. So we'll go back up. We're ready to bring in the other table. You know, it was actuals ag. I'm just gonna keep it simple and call it actuals. But the file name is actual ag. It has a header. Okay. So here we've got room type, month, reservation counts, days stayed, right? And these different. Room type, month, number of rooms. So let's look at the columns here. I want to compare the columns. We need to, I want to prep these just a little bit more. So before we merge them. So we can look at the actual, plans columns and the actuals columns. So I'm going to do a little bit more planning. In the merged data set, right, and we saw this already, this is what we want these are the variables that we want. And there might be a couple of statistics on either side, right? So for example, number of rooms is in plans. We can add that in there, that's fine. Let's call that number of rooms. What else does plans have that we want to keep? So we've got the sum of revenue bar, sum of revenue food, sum of revenue. I think that's everything, right? So room type, month, number of rooms, and then these 4 revenue variables. Right? So here we've got room type, month. We also have reservation counts, days stayed counts, and then the 4 revenues. Right? So we can add in, I'm fine keeping reservation counts and days stayed counts. But the main, so when we're merging, the thing is, we're going to need to match up these 2 tables. What are the variables that we're going to want to match on? Yeah, room type and month are the 2 variables in each of these tables that we want to match on. Right? So sometimes you might just match on one variable, like if you have a customer ID in one table and a customer ID in another table, and then you know, one table has like their personal information and the other table has like their purchasing history, right? And then the only column that's the same in the 2 tables is customer ID, and then you might match on that, fine. But here we want to match on 2 variables in each table, right? We want to match on room type and month. So, and then all the other variables are going to fall in according to that. So, in SQL language, this is called join on, and then you'd have your variable names. And in Python as well, when you're merging, it's also the on. So the variables that we're going to join on are room type and month. And then when we're merging, some of these variables are unique to each table. So the number of rooms is unique to here. The reservation counts and the state counts are unique to this table. So when we merge those, we don't need to rename them. Right? But these sum of food, oops, sum of bar, sum of food, sum of, I must have misspelled this, but it should be room, right? The revenue bar, revenue food, revenue room, revenue total. Those ones are essentially the same names, but we want to append those with a suffix of like planned or actual, right? So Python has, Pandas has some great functionality with the merge function to do this. But to do that, we need to prep these just a little bit more. And first of all, I think I need to make sure I revenue, room, sum, foods, beverage. But the actuals are fine. Did we, why is food here? Oh, I think I put the columns to keep, I put food twice. Yeah, it should have been rooms. So I'm gonna have to go back and rerun this because plans is gone. Probably from the start because I've just been resaving over the top. Okay. Okay, so now we've got revenue bar, food, rooms. Great. Okay, so right before you merge, it's a good time to drop any variables that you don't want in the columns, and it's also a good time to rename the columns. So that's what we're going to do here. So with the actuals, I'm going to drop. I don't want this unnamed. I should. It's probably just when I'm importing it. I want to drop that. Do I want to drop anything else? Nope. I think that's all. Okay, so I dropped that unnamed. For plans, do I want to drop anything? No. Okay, so, but for plans, I do want to change the column names. So I want room type, month, number of rooms. So I'm just going to call this, for now, I'm just going to call this bar. I'm going to call this food. I'm going to call this rooms. And I'll call this total. That's normally I wouldn't keep them that simple, but when we merge, we're going to be able to change the names using the merge function. And then for actuals, well, let's see this plans. Right. So now I've changed the names. Okay, so let's do the same thing with actuals. I'm just cleaning these up before I merge them. With actuals, I have room type, I have month, I have reservation counts. Just call these reservations. Just call these days stayed. Let's call this, okay, so this is room, food, beverage.
The order should be the same.
Yeah, the order should be the same. Otherwise, I'd be renaming, actually naming them incorrectly. Total. Okay. Okay. So now plans and actuals have the two columns that I'm going to join on, room type and month, they have the same name. Reservations, days stayed, number of rooms, those all have different names in the two tables. That's fine. When I merge them, they're just going to keep their same names. But if you're merging on room type and month, and then you're going to merge the bar, food, and rooms and total from the two tables, those are going to collide, right? And it's going to say, oh, you have columns in the two tables that have the same name. So how are you going to deal with that? So the merge function allows you to create suffixes for each of the two tables when you're merging. So let's look at the merge function here. So this is a very sensitive function. The merge is a function that you use on one data frame in order to merge it with another data frame. So it's not like it's not a function on Pandas module where you're putting the two data frames in as parameters. You're choosing one of the two data frames as kind of the parent data frame or the reference data frame, which here, right, is data frame. And then you're calling the merge function on that data frame. And this is called, oftentimes when you're merging, we use the language of left and right. So you have these two data frames, left and right. So the left data frame is going to be the reference data frame. And then, and you'll call the merge function on the left data frame. And then the first parameter in the merge function is the right data frame, right? So, and then the next parameter is how. And this is coming straight out of SQL. So in SQL, when you're joining tables, you have different kinds of joins. And we'll talk about this in a minute. You can do inner join, outer join, left join, right join, cross join. There are at least kind of 5 main types of joins. So we'll decide which one we want to do here. The default is inner, but for data science, oftentimes the default is left, but we'll talk about this. And then on, this is where we choose the variables that we're merging, the two tables on, that we're joining the two tables on. And remember, we want to join on the variables room type and month. So for on here, we're going to put a list with those two variable names. If you don't do that, if you just leave on equals none, it's going to join on all of the variables that have the same name. But for us, that's not good because we have a lot of variables like the sum, the beverage sum, the room sum, the total, right? All those have the same names and we don't want to join on those. So we have to specify on variable. In some merge is very accommodating. Say the two variables that you wanted to merge on it's actually the same variable, but in the two tables, they're named differently. In that case, you could use left on and right on. And left on would be the name of the variable in the left table, right on would be the name of the variable in the right table that you want to merge on, although they have different names, right? But I almost never use these because I would prefer to change the names of the variables before I merge so that I don't have to use these. I can just use on, right? And then same thing with left index, right index. We'll ignore those. Sort, we'll do that afterward. Suffixes, this is the other one that we're going to use. The suffixes is if you have variables in the two tables when you're joining, which are not the variables that you're joining on, but other variables, right? And then you want to preserve them or keep them distinct and you don't want to join on them, then you can specify suffixes to be attached to the end of each of those variables for the left and the right. So the X, this underscore X, you can replace this whatever you want. So it's a tuple, and whatever you put for the first item will be the suffix for the left for variables in the left table, and whatever you put for the second one will be the suffix for variables in the right table. So that's so right now, do we have a preference for which table is right or left? So if you know that the two tables, for example, plans and actuals, if you know that the variables that you're joining on, room type and month, are full in each case, then it doesn't really matter how you join them. You can join them. You can use a left join or a right join, right? Or an inner join or an outer join, wouldn't matter. Is if you have like a unique instance of each room type and each month in both of the tables, all of the joins will do the same thing, right? Most of the time, that's not the case. Most of the time you will have like a reference data set, which you're using on the left side, right? Especially in data science. A lot of times you'll have like a master database, right? For example, like your list of customers that has all your customer IDs, right? And then you'll have a second table, which is their purchases, which is not a master list of all your customers. It's just their purchases, right? And then the master list will be the left one, and the purchase table, for example, would be the right one. And in that case, if you want to preserve all the IDs that are in the master list, then you use a left join. So let me show you what the joins are, for example, first of all. So this is, you can find this in Google, just Google images, types of joins, SQL. You'll find these kinds of tables that are convenient. They all say the same thing. Is there a summary of them? So anyways, I don't do that. Okay, so it's hard to see. You see this? Okay. Okay, so at the top here, so you have the two circles. These represent the left table and the right table. Okay. So the top table here is an inner join. So this jargon is all SQL code, right? But it has direct correlates to pandas. So select fields, these are just like the columns that we're choosing in the two tables. From table A, left join table B, right? So table A here is the left side and B is the right side. And then you have the type of join. So you either have an inner join, you have left join, a right join, this is also a right join, and then you have an outer join, or to call it a full outer join. So so an inner join, you can just think of these as set theory, right? An inner join is essentially the intersection, right? The intersection of what? The intersection of the whatever variables you're joining on, it's going to be the intersection of those. So if one table has a master list of IDs and the other table has a subset of those and you do an inner join, you're only going to preserve the intersection. You're only going to preserve the records from the two where there's the intersection, right? If you do the left join, where the left table is a master list and the right table is a subset, it's going to preserve the whole master list, and it's going to append the subset to those records where they apply, and you're going to end up with a lot of null values for the record, for the records in the master list where there's not where the subset didn't appear, right? Which is fine, right? Sometimes you'll have like, okay, maybe they had a purchase and then these guys didn't have a purchase and they had a purchase they didn't. So you're gonna have a lot of like null values on the right side of the table when you join them. Right join is the opposite. So it's basically the same as the left join, but it's just left and right. So if whatever you're using is it's gonna preserve all of the variable that you're joining on, which is called there's a key. It's going to preserve all of the values of the key on the right table and match whatever's on the left to those. And if there's any on the right that are not in the left, it'll preserve those and put in null values for those left table variables that get joined over. Same thing. Yeah. So here, where the key is null, you can decide whether you, so here if the, so what I explained is the left join or the right join. And then of course, once you have joined those, you can filter out the null values, right? The ones where you didn't have any matches, you could filter those out. And that's what they're doing here with the left join where the right side is null. You can filter those out and just get this left part. So anyway, so what do we want? Well, for us, it's not as critical because both of these tables, as far as we know, right? Both of these, well, which of these tables, the plans or the actuals, is definitely gonna have values for the room, for every room type and month. The plans or the actuals. Yeah, the plans are gonna be the full data, right? The plans are gonna have every room type by every month, right? The actuals we don't know, right? Say like one room type was not available during a month, and then there might be null values, right? Now, I think that's not the case in this data set, but for us, plans can be our left-hand side, the master list, because we know, right, based on the, like we saw the table, right? Every room type every month has some value. So we know that that is a full, that key of those two variables, room type and month, is going to be full, right? And then, so we can use the plans as the left side, and then we can merge it with the actuals as the right side. Okay, so let's do this. So we're going to take plans. We'll call this merged, the new table that when we merge these two, we'll call that table merged. So we'll have plans merge with actuals on room type and month. How? So since plans has the full every room type for every month, we'll use a left join, because we know that the left-hand table has all of the room types in month, right? So we'll use it as left. And then for suffixes, we don't need left on, left index, right index sort. So for suffixes, we need this. Okay, now here, recall in my ideal data set, the suffixes that I wanted are planned and actual, right? So we can put these in as the suffixes. So where we have room, food, beverage, and whatever, we can have planned and actual as the suffixes. And since plans is the left side, then we can make this suffix planned and this suffix actual. Plan and actual. Okay, is there anything else we need to merge? Copy true, no. Indicator false, validate none. Okay, these are fine. Okay, so let's do this. Oops, what's wrong? Oh no. All right, so our variable types are not matching up. So let's just go back and double check. Plans, D type. Okay, and actuals. Okay, notice some differences. Yeah, month is going to be a problem. So these the room type should be object. That's a string. That's fine, right? But month here at plans, when we melted it from columns to from wide to long, we preserved the names, right? So here the months are actually like the names: January, February, March, right? And here the month are actually numbers: 1, 2, 3, 4, 5. So we have to change plans. We have to change these month names to numbers. Yeah. So how are we going to recode? Let's look at plans real fast. April, right? And in actuals, the months are actually names. So I'm going to do this using a dictionary. It's probably, I think, hopefully that'll be the fastest way. I don't know. So January is 1. February is 2. March is 3. April. I like using dictionaries to recode stuff if I'm coding from strings to integers, right? As long as it's not like too long. Or June is 6. July is 7. You could do these through queries, like query like all the cases where the date where this variable is January, and then set those equal to 1, and you could do it like that. I just think the dictionary is a faster, a more elegant way to do it. August, September, October, November. I tell you, all this like data wrangling that we're doing, this is like 90% of the analysis is like data wrangling. And when you actually get the final data and you're doing a linear regression or whatever analysis, like, oh, it's so fast. I swear it takes me like 3-4 months to like collect my data, wrangle data, and it takes me like a week to do the analysis. It's the data science, it takes the most time, the data wrangling. Okay, so I've got the month dictionary here, and now it's plans that I need to change. So plans, I need to relabel plans months. So the problem here is I've got this dictionary, and what I need to do is take each element of each row, right? Each month and each row, and run it through that dictionary, right? So if I put in this value into my month dictionary as a value, it's going to return 4 as the key, right? But you can't, there's some functions where you can run it aggregate, you can run it like on a column, and it knows what you mean. It knows that you don't want to run it on the whole column. It knows that you actually want to apply that function to each value in that column separately, right? But month dictionary is not a function. It's a dictionary, right? So we actually need a function that's going to take each row of this data frame, take the month variable and apply the month dictionary, right? Input it into the month dictionary as a value and reset the value of the month as that thing, right? So this is for pandas, this is where we use the apply function. So the apply function is extremely useful. I've seen people like trying to do this using like for loops or whatever, like a for loop, and they try to index every row of the data frame and like loop through every row and do this and that. You can do that. Pandas like strongly discourages you from indexing the rows and then like running for loops over it. So that's a Python like solution to this problem, but it's not a very pandas like solution to this problem. So pandas actually has this apply function. So what you do is you take plans and you apply. And then the apply function allows you to create a lambda function. Remember when we did sort and then you could use a lambda function and define your own key, right? This is the same thing. So you can do a lambda function here. And what we're going to do is we're going to apply lambda x, or we'll call this row. So when you run the apply function on pandas on a data frame, the default variable here in the lambda function is the row, right? It knows that you're doing this apply function like row by row. And so the handle, like the variable that it lets you manipulate in the lambda function is row. Right? And so that's how you grab a row, right? One by one. So this is the alternative to running like a for loop over every row of the data frame. You use the apply function and create this lambda row, and then now you have that row, and whatever comes after this is what you're going to do to that row to manipulate it, right? So what we want inside of that row, what we want is the month variable. So row month. And we want, actually, let me see. I think maybe we can specify just the month column here. Right, and then this should just be the month value, and then we want to plug it into the month dictionary. Let me just make sure. Apply, result type, and all right, let's try. Okay. So there it's recoded all of my months as numbers. Right? So that row, remember these, it just took these ones that were like, January, whatever, and it turned them into numbers, right? But it didn't actually save these into that column, right? So now we have to take this thing that we wrote and we have to save the plans month column as this thing. Right? So I'm going to take plans month and hope that this works. I'm always like, whenever I'm doing like row operations on data frames, I'm always like, you usually have to do it like 2 or 3 times to make it. Oh, okay. And by the way, it prefers that you use that. I think. Well, let's just see if it did it anyways. I've had to do this like 3 or 4 times. Let's see, plans. It did it anyways. So it gave us a warning. It didn't like it. Probably there might be a cleaner way to do it. Well, because probably, let's see. Let me just try one more time. Okay. I want to. I'm just going to try this on a second data frame. So, okay, so plans 2, if I do look, and then I think, is this going to work? Yeah, it did it anyways. Okay, so somehow it doesn't like exactly, it doesn't like us, it doesn't like how we're doing this exactly, but it does it anyways. Oops. Okay, so there it is. We've, and now if we look at our, data types, and our actuals, right? So the room type is a string, the month is an integer. These are floats and these are integers. It doesn't matter because we're not joining on those. And even when we do like side-by-side calculations with those, it won't be a problem, right? If we're like trying to calculate using one to calculate a percentage of the other, right? Like floats and integers, you'll be able to do math on those. So we don't, I mean, we could change these to floats if we wanted, but for now, the most important thing is that the variables that we join on have the same data type, right? Okay, so let's go back down and see if we can actually achieve our purpose here today of merging these files. So we have plans with our newly, we've recoded our months from strings to numbers. We've got our actuals. And there we go. Voila. What's wrong? Bar, food, rooms. So food is the same. So these variable names were not quite the same, right? And so it didn't, right? Where food was the same, it applied the suffix, but because rooms and room were different, and because bar and because beverage were different, it just preserved those and it didn't add the suffixes. Damn it. Okay, so let's go back up. Fortunately, we didn't, we can change these. So, okay, bar, let's just call this here, let's call this one bar. This is room. Okay, so bar and bar, food and food, everything's good. You're gonna run those again. Okay, just make sure. Okay, that's good. We don't need to run this again. Okay. So I think that's what we wanted, right? So now we've got room type and month. We've got number of rooms, which was in the plan. We've got the bar plan, the bar actual, the food plan, the food actual, the room plan, the room actual, the total plan, the total actual. We've got reservations and we've got days stayed. Right. So to finish up today, what I want to do is just reformat this table just a little bit so we're ready for analysis. So all I want to do to reformat this, number one, I want to sort by room type and month, right? Because these months are all kind of out of order, just to make it clean, right? So it's like January, February. And then also I want to rearrange my variables. I want the bar, food to be next to each other. And I want these variables like number of rooms, reservations, days stayed. I want to move those to the front here, right? So, so we want to do some, first I want to do the column operations. I mean, I don't think the order matters that much. So first thing, yeah, and calculate new variables. We'll calculate new variables next time. So just to format the data frame before we export, merged. equals, so this is to resort the columns. We just write the columns that we want. So let's just copy and paste. Let's get the columns here, right? And then we can just kind of reorganize these. So room type and month, number of rooms, that's fine. I want days stayed here. And I want reservations here. Okay. So I'll just kind of keep them in groups. So room type and month, this is kind of my key of the database. Number of rooms, reservations, and days stayed. These are just, I'm not going to be comparing these just as reference variables. And then bar plan, bar actual, put those here. Food plan, food actual, put those there. Room plan, room actual, and then total plan and total actual. And you just have to make sure that you don't, drop any quotation marks and that you have a comma after everything, and then, the square brackets. So this is columns reordered. This is just a list. And then you can just save merged equals merged columns reordered, and it will just reorder them. Right, so number of rooms, reservations, days stayed, bar plan, bar actual, food plan, food actual, food plan, food actual, total actual. And lastly, I want to sort values. Actually, here I want to put month and room type like this. I want the month first, yeah. And then here I want to sort first on month, and then, so this is actually a function, and then you can put a list, room type. And did sort values require a variable name? Parameter name? Oh, just by. Maybe we can just try it, and maybe we can do it in place. Okay. So, and then we can reset index. No, oops, that was a mistake. Does it drop values? No. Damn it. Well, anyways. Oh yeah, there we go. Okay, so that's our data set, month, room type, right? And then, so you can see we should have, if we scroll down, we should have all 6 room types. So 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, right? And it should just go until 12, 6, right? And then we've got everything. Okay, so this is like super clean, super formatted. All the columns are named how we wanted. They're ordered properly. It's sorted. This is, now we're ready to start calculating some variables and do some analysis, right? So, so for last step, we're going to export the merged data frame to merged. So merged to Excel, merged. We have to like specify, it specifies headers for us, right? That will do it for us. There. And then we can verify That's our data, right? And I mean, well, we could have removed that index without the index anyways, but yeah, that's fine. Okay, so just to recap today, I mean, this is, the reason why PwC gave us this data set was because it basically pushes every single, button. Like we have to reshape, we have to like recode, right? From January, February, from strings to numbers, right? We had to, yeah, from wide to long and some from long to wide. We had to join on more than one variable, right? We had to add suffixes to some variables. This is, it took us a while, but this is finally kind of the culmination of everything that we've been doing these last 3 weeks. And now this is kind of the climax, I would say, of of Python 201, right? Like once you have this data set, everything from here on out is like stuff you could have done in Excel, right? So, to calculate our 90%, I mean, we could do this, it'd take like a minute right now, we could do it if we want, right? But from bar plan to bar actual, now we just have to divide, right? We can create an extra column here called, bar percent or whatever, right? And see what percentage is the actual of the plan. It just divide this one by that one, and then we can see, and then we can run a query on it to see in that column of bar percent, show us the rows where the percent is like lower than 0.9, right? And then we can start identifying. So we'll do some of this, like creating these new variables and then using these to start doing some exploratory analysis and start to actually answer the question next week. Actually, I won't be here next week. So I'll be in Shymkent. So I'm gonna do, but I don't want to get out of order. So I'll do session 4, I'll do some of the analysis. I really wanted to do this part in person today because it's pretty messy. But I think the next part, when you see, it's pretty straightforward. I'm just creating columns using, simple like division or operations and simple queries, stuff that we saw all the way back in session 1. So I'll record session 4. I'll throw that up on YouTube, and then we'll meet again in session 5 in 2 weeks, and I'll show you how to use merge again to make a data series, to make a time series of these, so we can actually start visualizing room type, over months on the x-axis. On the y-axis will be the percentages of that they reached the plan, and we might have six data series, right, for each room type. So how do you take this and make a data series, right? Because this x-axis, this is not the axis that we want for a time series, right? I mean, it is like the month is, but then these room types are going to be a data series within this x-axis, right? So how do you convert this with the analysis that we've done to time series data? And so that'll push us a little bit. Like we'll be using shape and merge again when we do that in session 5. So okay, we'll stop here for today. All good in Zoom land? Any questions in Zoom before I stop the recording? Sure, Adil got a question. Yeah, what's up? Yeah. Does anybody taking the Python 101 skills test today? The 101? Okay. So Adil, you're taking it? Anybody on Zoom? Anybody else on Zoom taking Python 101? No? Okay. Yeah. So, okay, so we'll do Python 1. I'll do Python 101 today for Adil, and then Python 102. So Python 201 in 2 weeks, we'll only have the tutorial for an hour from 3 to 4. This is in 2 weeks. And then at 4 o'clock to 4:30, we'll have the the skills test for this for 201, and then I'll also open the skills test for 102. Yeah, yeah, in 2 weeks. All right, see ya. Yeah. Okay, Adil, can you give me about, okay, I'm gonna end the recording here and then let's keep, we can